Hello again, and we're back, and once again, we're going to be taking a look at various patterns. In this case, we're going to be talking about recursive formulas. Now, again, a recursive formula is something that uses the preceding term to define the next term, okay? Now, wait a second, preceding term, next term, wait, that sounds kind of like something that we've messed with before. Let's go back to what we covered on the first day when we were talking about sequences. Each number in the sequence of the term ended up being, okay, a sub nth term is the nth term, first term, second term, third term, and then we talked about the a sub n minus 1. That's the previous term, okay? That is what we were talking about. So now we're going to be talking about the a sub n minus 1, or the previous term. That, by definition, is what we're going to be basing things on for our recursive formulas. So the recursive definition is always going to be two parts: the value of what the first term is, and then some recursive formula. That means if you are looking to get full points, you need to make sure that you are giving me both of these things, okay? For a recursive formula, you cannot just write a definition down. You need to also have a first term, all right? Moving on, here we go. You're asked now to write the first 5 terms of the sequence defined recursively. I'm told that my first term is just going to be a sub 1 is 4. And then it says to find the nth term, you take 3 times the previous term plus 1. Well, what is the previous term if we're looking at the second term? Well, that means go to the first term. So all I really need to do is say to find the second term, I'm going to plug my first term into my formula here for n minus 1, and I just do the calculation. Not difficult. So to find the third term, what am I going to do? Well, I'm going to take 3 times the previous term in the line, which in this case is 13, so it ends up looking like this: 3 times 13 plus 1. Okay, and trying to find the fourth term, again, we just plug in the 40. And then to find the fifth term, we're just going to plug in 121. So to come up with my recursive list, there you go. Not incredibly difficult. Again, repeat this if you need to, but honestly, for a lot of people, this is a pretty easy thing. And the problem is you're now going to want to turn everything into a recursive formula. Recursive formulas are nice for small sets. If it's a big one, for example, if I'm trying to figure out what your mortgage payment is going to be in 30 years, if you pop that thing into your calculator, it's going to sit there and grind on those numbers for a couple of minutes. That's why we like the explicit formulas. It gets me my answers for the 30th, year very, very quickly. But if I'm doing like 360 payments, trying to do something recursive is just a nightmare. All right, let's take a look at the second one. This time I've got 5 terms of the sequence that's defined recursively. This is my first term, and then here is my recursive definition. Again, first term, recursive definition, the 2 pieces that I need to always have for a recursive formula. Here we go, getting started. To find the second term, that's going to be, say, take the a sub 2, well, 2 minus 1 is 1, so that's a sub 1 there, so I'm going to say it's going to be that value of 1, so it just becomes a sub 2 is just that there, not difficult. Then I'm going to plug 4 into that spot for the next one, which is going to get me up to 19. I substitute 19 into that spot here, and then 364 for that one. You can see how these numbers get very, very large very quickly. Okay, hopefully no questions, comments. All right, let's move on to kind of our last page of things. Okay, come up with a recursive formula for each of these. Remember, when you're asked to come up with a recursive formula, first thing you're going to do is you are going to write the first term down, a sub 1. Got it. And then what do you do to each successive term? I'm going to say I'm subtracting 5 from each one. Now again, explicit arithmetic sequence, you're going to have to write that using your common difference and all that. But for a recursive formula, all you need to do is take the previous term and subtract 5. So I'm going to say previous term is here, subtract 5 from that. That's my recursive definition. As I said, some people are really going to like recursive definitions and don't want to have to go back to the explicit ones. Okay, take a look at this one and see if you can come up with, once again, your recursive formula. Give me a second. Pause it if you need to. And here we go. My first term is 4. Got it. What do I do to get from one term to the next? Well, here what did I do? I multiplied by 2, and then I multiplied by 2 again. Then I multiplied by 2. So all I'm going to do is I'm going to say take the previous term, which is a sub n minus 1, and multiply it by 2. Cool. All right, give it another shot here. Take a look at this one. Pause it, copy down what you think the the recursive formula should be. Okay, and we're back. A sub 1, got it. What did I do to get from one term to the next? Well, I'm just repeatedly adding 4. So I'm going to say a sub n minus 1 plus 4. Not complicated. Take a crack at this one. This one's a little bit more of a challenge. Pause it if you need to. Okay, here we go. First term is just 1/2. Everybody should be able to get that. What did I do to get from this term to this term, this term to this term, and this term to this term? Remember, what did I do to this term to get to this term? What do I do to this term to get to that term? It's actually pretty simple. I'm just multiplying by 1/2 repeatedly. So you can do something like this, where you say 1/2 times a sub n minus 1, or you're going to have those people who want to say, well, I'm just taking the previous term and dividing it by 2. Both work, and both should get you okay answers. All right, last one. See what you can do here. This is easy. Everybody should get that. The next part might be a little bit more of a struggle. What did I end up doing to get from one term to the next? Well, again, it becomes a lot of plug and chug. You sit there going, okay, well, could I say, and what could I do? Well, I could take this times a number, and then it's not a repeated addition, and it's not a repeated subtraction, it's not a repeated multiplication. Some of these do take a little more work. The actual answer in this case is I'm going to say, well, 4. If I take that times 3, that gets me up to 12, but I'm 2 less than that, so maybe if I add 2. Next, I'm going to look at 14 here. If I take 14 times 3, that's going to get me 42. And once again, I'm 2 away here. What do I do to that? Multiply it by 3. Oh, wait, there it is, that pattern there. Okay, folks, that's it for the day. You've got Math Excel to play with tonight, and I'm also going to be posting a review worksheet. I'd encourage you to do that one and to take a picture of what you did, and I'll let you take that for points so that those of you that are looking to bump your grade a bit, that might be helpful. All right, have a lovely day today, and talk to you later on.